let us look at a series of ellipses, varying the eccentricity. So here we have an ellipse of eccentricity 0, also known as a circle. Let us see what happens when we increase the eccentricity. You can see that, yes, as we start to increase it, we've got it up to about 0.3 something at the moment, and you can see, yes, the shape has become a little bit flatter. Continue to increase the eccentricity. So it comes up to about 0.6 now. It's distinctly flatter. We are keeping the major axis constant. Here's the major axis from here to here. Semi-major axis is from here to here. Semi-major axis is being kept as 1. So let's keep increasing the eccentricity further. You can see the ellipse gets narrower and narrower. 0.866, it looks like this, and continuing to increase it as it approaches 1, you can see that, yes, thinner and thinner, and then of course when it approaches 1, each end is going to start resembling a parabola. But when the eccentricity is high, you can see we're around 0.99 here. It is long and thin. Now let's go back to the circle. The blue dot represents the center of the circle. Now we can talk about the center of an ellipse. Let's increase the eccentricity a bit more. You can see the blue dot remains in the center. But the blue dot is not necessarily the most significant point on the circle. Let's see other candidates, or one other candidate, for being the most significant point on an ellipse. Now here we see a circle once more, and it looks like the center is now marked in green rather than blue. But this is not the center, or at least it will not be when we start increasing the eccentricity. So just increasing the eccentricity to about here, 0.068, you can see the green dot is split into 2. So there's actually 2 significant points here. We call them the foci of the ellipse. Each of them is known as a focus. It seems that the shape of the ellipse hasn't changed a great deal when we increase the eccentricity from 0 up to 0.068, but the 2 foci separated themselves and have moved slightly out. So the focus is some kind of an important point for the ellipse. We will come on to see some ways in which it is important. So increasing the eccentricity further, we'll get it up to about 0.2 here. We can see now, yes, the 2 foci that moved further away from each other, and now we can see that, yes, the shape of the ellipse has started to change from a circle. It had changed earlier, but the change was imperceptible. Now it's becoming more significant. And again, moving further out still, you can see when we get to about 0.5, the 2 foci, they're about halfway out to the end. That will happen for an ellipse of eccentricity 0.5. Increase it still further, and you can see that once we get up 0.83, we can see that, yes, the ellipse is much longer and thinner, but each focus is near the end of the ellipse. And then taking it up to Well, about 0.95. The foci are getting closer and closer to the end of the ellipse. So the foci move out as the eccentricity increases. Now let us consider an ellipse here of eccentricity 0.75. Let's now consider a point on the ellipse. It's here along at the right hand part for the moment. Let's move it round a little bit. We move it round to here, a little bit round the ellipse, and you can see what we've done is we've joined this point on the circumference of the ellipse, we've joined it to each of the foci. It turns out that as we move round, and we were to add up this distance and this distance, as we move round, the sum of the two distances remains constant. So the foci certainly have an important role to play in an ellipse. For example, the Earth moves around the Sun in an ellipse. But the Sun is not at the centre of the ellipse. The Sun is at one focus. So, in the world around us, or in the universe, yes, the focus of the ellipse is a significant thing. It's important to note that in the case of the Earth, or indeed any other planet going around the Sun is at one focus, the other focus is empty. Well, let's do the same thing again, but now we've added in the dotted line, the tangent at that point. So we have the tangent here and the line joining this point to each of the two foci. Well, it turns out if we look at the angle here, the angle between this line and the dotted line, and the angle between this line and the dotted line, they are the same. We move further along, the two angles are the same. Further along still, the two angles are the same. The angles themselves may increase and decrease. Here they're approaching 90 degrees each, but they do remain equal to each other. So it's almost as if you can consider if you were to send a beam of light out from one focus, it would reflect off the inside of the ellipse and arrive at the other focus. So when it comes to the ellipse, the two foci, one focus and the other focus, they are indeed significant points for the ellipse.